Okay, so in this next section, we're going to be reviewing sequences and series. So let's begin by this problem where it says evaluate 4 plus 10 plus 40. So our first step is we need to figure out how many terms are in this sequence. So we can go ahead and go to our calculator. If you click program there, and then you click enter on Academic 22, and then click enter again, then you can go ahead and see that in the programs we have between these two options. This is arithmetic because each term in the sequence is adding by 6. We can go 4 plus 6 is 10 plus blah, 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 all the way up to 4. So we're going to go ahead and go to arithmetic sequence and series. Now, since we're figuring out how many terms there are first, this isn't going to be a series, this is going to be a sequence. And so we're looking for the sequence and how many terms there are, aka the index of this item 40. This will give us how many. So we type in AN is 40, the final number. The first number is 4. Go ahead and type in 4. The common difference we just said was 6 because 4 plus 6 is 10. And we get n equals 7. So there are 7 terms in our sequence here. Now, if we want to solve for what the actual total is, we go to arithmetic again, but this time we go to series. And so we can go ahead and go enter, and then enter. Whenever you want to click one of these things, you click enter. And so then you're going to go for series sum because we're trying to find the sum of them. We know there's 7 items based on our previous little program here. A first item is 4. Last item, 40. 154. So we can see on our answers, this is 154. And we didn't even need to do a single thing on paper because we had it all on the calculator. Next up, we have this little problem that I had to correct. It's actually 1,118,480 is what it equals. And so to do this one, we're going to go back to our calculator. We're going to go program again. And since we know that each term is multiplied by itself and to a new term, and we're adding them all up, that's what this summation means, then we are going to go ahead and do a geometric series this time. So geometric, because notice how if this was, for example, 2 times n, or how about just, yeah, if it was just 4 times n instead of to the exponent of 2n, 4 times 2n, then in that case, that would be an arithmetic because you are adding a certain amount each time versus multiplying a certain amount each time with exponents. And so geometric sequence and series is what's next. And then we know it's a finite series because we're trying to find, okay, what number are we ending with? That's what it's asking by finding t. How many terms are there in the series where the starting term is n equals 1, which is 4 to the 2 times 1, which is 16. How many terms are there when it equals this number here? So we're going to go ahead and go to finite series. And you're going to want to say that you are given the last term, when in reality, you aren't, but it will ask you later. It won't ask you for it. So you click number of terms because you're trying to find the given number of terms. So you click, the last term. And then you're going to say that you solve for the last item. So in reality, that previous screen was really asking, what are you going to solve for, the last item or the number? And in this case, you're going to solve for the item first because otherwise you will need to give the last item in order to find the number of items. And so we need to find the last item first in order to find the number of items that there are. And so we click on the last item. Series sum is going to be that number. Let me just type it in. 11, 1, 8, 4, 8, 0. And then we know the first item is going to be when n equals 1. So we plug in 1 for n, and we get 4 to the second, which is 16. 4 to the power of 2 is 16. The common ratio now, this could be tricky, but notice how for every single term, if you were to increase this n by 1 and say to the power of 2, you're just multiplying by 16 again, because 4 to the power of 2, it's multiplying that number again. So that's how exponents usually function. And so here we just type in 16 again. And so we get an AN of that number right there. So I'm going to go ahead and write this number down. 10, 4, 8, 5, 7, 6. So now we're looking for if our last term, remember that's what we were looking for. If our last term, AN, equals this, then what is T? So in reality, we're looking for 4 to the 2 times N equals 10, 4, 8, 5, 7, 6. And that's because our final term is going to equal whatever this N is here, since we found our final term and it gave us in the calculator what the full number is. We just need to find, well, what number to the multiplied is it going to be? Because that's what the summation does, is the summation from N equals 1 to T of 4 to the 2N equals 4 to the 2 times 1 plus 4 to the 2 times 2, and so on and so forth. So we then have 16 plus 16 times 16 plus 16 times 16 times 16, and so forth, because that's to the third. And so what we're looking for is, oh, if we're adding up all these terms and we know what the final term is based on what we just did in our calculator, then it's just going to be 4 to the power of 2 times what equals that number. So in order to figure that out, we need to do a little bit of algebra here. So if any of you remember what logs are, we have, in reality, this is just 4 to the power of 2n equals 16 to the power of n, because that's our common ratio, remember? And 4 to the power of 2, see how 4 to the power of 2 is 16? And then we just leave the n there. That's what you do when multiplying with exponents there. And so we're just saying, well, 16 to the power of what equals 10.048576. Now, if you don't know how to do this algebraically, what I would do is I would do 16 to the power of 6, and then 16 to the power of 2, and then to the power of 8, and then to the power of 9, and then to the power of 5, since you're given options here. So you do 16, let's say, to the power of each of those, but how you would do this algebraically, how you would solve it, is you would do 16 to the n equals, well, we've already written it out there, so I'm just going to move it over here and say that it's actually log base 16 equals 1004.8576, and so we can then say, based on this answer, which how you do that in the calculator is you go to, where is my log base? I believe it might be in math. Log base. So you have log base and then 16 of this number, this really long number, 104.8576, and you get 5. So our answer here is going to be 5. Next up, we've got an infinite series. So if I may remind you here, an infinite series is one in which we have n equals 1 or any other number on the bottom there, all the way to infinity, and then we have some common ratio, r, to the power of n. And so this is going to equal a finite number unless r is greater than 1. So if r is greater than 1, then this is called diverges. So if you get a problem like this, there will be diverges. You'll likely see an option that says this diverges or something like that. And it only diverges if this number right here inside of the power to the n is greater than 1. Now, when we get a problem like this, it's a bit more complicated because look, there's 2 of these numbers. What do? Well, in order to get one number and make it a little easier on ourselves, all we need to do is multiply each of them up. So we can say that 2/3 times 1/4 all to the power of the n is equal to the same thing. We're just using multiplicative rules here. Now, it wouldn't work to say 2 to the power of 3 to the n times 1/4 to the power of like k is equal to 2/3 times 1/4 to the power of n times k. That would not work. Only if the exponent here is the same, or in this case, both n. So we see that 2/3 times 1/4 is equal to 1/6. So we can say that our ratio is 1/6 when n equals 1 to infinity. So we can say our common ratio of this infinite series is 1/6, and that our first term is when we plug in that 1 for n, because it's the one at the bottom of the summation. So a1 equals 1/6. And then we're going to go to our calculator, because there's a handy-dandy calculator program that's built in here. If you go to geometric sequence and series, because remember, it's being multiplied by a thing by itself over and over and then added. So this is geometric. And then we're going to go to infinite series. See how it's geometric has the infinite series button. And then we're looking for the series sum. We know the first item we already established is 1/6. The common ratio is 1/6. And so we see here that our answer is 0.2. Okay, so next up, we've got a different way of expressing these little terms here. So we know that then this is just telling us that our common difference, or since we are multiplying a 2 by an each time we get to the next term, because a to the n plus 1 means that you're doing the next term after an. So like, for example, a1, we know it's equal to 4. We know that an 1 plus 1 is equal to 2 times a1. So that would equal 2 times 4, which is 8. So we need to find the sum of the first 15 terms. So we know this is a geometric, since it's multiplying by itself, a geometric series, because we're adding up each term. So the sum. So once again, we're back here in the programs. Hopefully you remember how to get to them. And you're going to do a geometric, and you're going to do a finite series. And you are given the number of terms, and you are looking for the series sum. And so a1, the first item, is 4. The common ratio is 2. The number of terms is 15. And so we are then given the sum right here in our calculator, and that is 131,068, which is correct. And so next we get a fun little one, and this requires that you know the formula for an infinite series. So I'm going to go ahead and give that to you right now. And the formula for an infinite geometric series like this, where you have the n. Now, this may trip you up, this negative, but all we're saying, if we do a little algebra here, n equals 1, we get 1 over y to the power of n. And so we see 1 over y is our common ratio. It's just imagine it like y equals 2 is 1/2, y equals 3 is 3. And so this can be an infinite geometric series here, because it's r is less than or equal to 1, then it will converge at a certain value. Because remember, we said if r is greater than 1, then it diverges and it won't have an answer. And so we see that this infinite series has a ratio of 1 over y. We know it has a starting term, a1, of 1 over y to the 1, because n equals 1 here at the bottom. And so that'll just be 1 over y. So if you want to know the formula for an infinite geometric series is a1 divided by 1 minus r. So if we go ahead and plug in each of the numbers for our ratio and our a1, we know a1 is 1 over y divided by 1 minus 1 over y, since that's our ratio. So then, if we go ahead and do the normal rules of multiplying instead of dividing, we can do 1 over y times 1 over 1 minus 1 over y, which we just multiply the top and bottom. We do 1 over 1 y times 1 minus 1 over y, which we will get 1 over y minus y divided by y, which is just 1 over y minus 1. And so we get the answer D. So this is a bit more algebra. Next up, a series includes the consecutive terms of these, and we need to find a1 and an given that a1 is greater than 0. So if we take a look at these here, we can immediately eliminate a couple options. So we know at a1, n is equal to 1. So if we plug in 1 for n of these, then this 4 times 1 plus 1 should equal 3, because that's a1 right here, and then this is equal to an if you're looking. And so if you plug in 1 for n right there, 4 times 1 plus 1 is actually equal to 8, so it cannot be a. And then the same goes for this one. If you plug in 1, you have 4 times 1 minus 1, which is equal to 0, because this is equal to 0, and when you multiply by 0, it's 0. So that's wrong. And then if you get into this next one of 4n minus 1, we plug in 1, and it looks like we get 3. So this one could be one of our options. Same goes with this next one, 4 times 1, and we get 4 here, which is indeed this, in agreement with this term. There it is. And then this next one, 4 times 1 plus 2 is 6, which means this is not a viable option. So now it's just between these two terms. And now what I want you to do is I want you to see if you were to, we know that if we go ahead and say 27 minus 23 is, we know, equal to a factor of 4. So we know this number is correct right here. It increases by 4 each time we add a term, or each time we put the term in. However, if the starting term was 4 and we're adding 4 each time, then each of these numbers should be a factor of 4. So that means they are able to be divided by 4 without being a weird fraction or decimal. And that does not work for if you have the first term of 4. But if you have the first term of 3, and then you multiply 3, if you then multiply 4 by some number, such as 1, and subtract 1, then you get 3. But also, if you go ahead and plug in the number, let's say 6 minus 1, that's 24 minus 1, which is indeed, wrong thing, 23. And so we can put a little check mark in there and say, oh, look, if we put in the number 6 here, then we can get the number 23. Whereas if we try and put in any other number for 4 times n here, so like 6, that'll get us 24. And 24 is not in this sequence. So then it can't be D. It has to be C. Next up, we're expressing a series in sigma notation. So what we're going to do here is we're looking for, okay, it's a geometric. And we know geometrics can be expressed, even if it's infinite, as n equals 1, infinity. And we know it's going to be a1 times the ratio to the power of n. So if we're looking, what's the common ratio between each of these numbers? Well, we know the common ratio is 1 over square root 3 because it's dividing by square root 3 each time you see here. So we know that r equals 1 over square root of 3 to the power of n. Now we just need to find a1. So what we do to do this is we need to find which number, if we know the first term is 9 square root 3, then we need to find what a1 equals 9 square root 3 when n equals 1, right? Because the first term, it says right here on the bottom of our sigma notation that n equals 1. Then we have a1 over square root 3 equals 9, I'm sorry, this was meant to be a 3, square root 3. So if we multiply on both sides the square root 3, then we get 9 times 3, which equals 27. So we know our a1 then has to be 27. And if we look in these options, only one of these has a common ratio of 1 over square root 3 and an a1 of 27. And it is indeed B. Okay. Next up, we've got a bit of a harder one, but we can use our calculators once again. So what I would recommend for this question is go to Program and then Academic 22. And since we're multiplying by the same thing the whole time, 1 over a to the n and so forth, we're going to go to geometric. But this time, instead of solving for anything, since we have a variable, we're going to need to do some info work. So we go to info, and we see that we have this formula up here of sum, and we're actually given the sum, so this is good. So that means we're going to be using this sum formula here. So I'll go ahead and write that here. S equals A times R, and you can look at how I'm formatting this in each one inside of the calculator so that you can use it later, where A is the first term, and then R we know is the ratio, and then K is the term. So we know that our first term is going to be 1 over a to the power of 2, because remember, this number down here, n equals 2, is our first plug-in number. So we know, now I know the a's are going to get confusing, so in order to make it less confusing, I'm going to change this in the formula to be b. So we know that b equals 1 over a to the power of 2. So we have 1 over a to the power of 2 times r to the k minus 1 over a to the power of 2, right? Okay. And then r minus 1. But, and I'm going to go ahead and erase this, hopefully you remember, and we're taking notes. So we now need to find the ratio. Well, it's actually pretty easy to find because it's just 1 over a, because this is what we're multiplying each time inside of this sum. So we can then just plug in and say, okay, 1 over a to the power of 2 times 1 over a to the power of k minus 1 over a to the power of 2 over 1 over a minus 1. And we know all of this equals 60. Oops. 60 equals all of that. And so we can actually now say that there is some simplification here. So if we're doing 1 over a, since we have the same base here, this is just 2 plus k now minus a over 2 to the 1 over a minus 1. And so if we do a little clever algebra here, we know that k is going to actually be equal to 5 here, because that's the top number on our thing. So if I go ahead and erase all of this to try and make more room, we know then that this is 1 over a, and we can actually just ignore what I did here and make it a little easier on ourselves and do, although it's going to be important for later, so we might as well. 2 plus 5 times, or no, minus 1 over a squared, or not a, 2, it's a. And we can go ahead and then divide by 1 over a minus 1, which is going to be 1 over a to the 7th minus 1 over a to the 2nd over 1 minus a over a here. So it seems that we kind of have a very painful algebraic problem here. And the thing is, because we have options here, we really, to your relief, and I was showing you the formula to get the formula in your head, we didn't need to do any of this. The formula is important to know, but we didn't really need any of this, because all we had to do was go to our calculator and plug in each option for each of these for A. So for example, math. You go to the math and then you go to summation. And you get, in order to do summation, you click this button here that says link above it, but it's really just an X. X equals, we know it starts at 2 and then ends at 5. And then we know that it's going to be 1 over a to the n. So instead of using n, we're just using x because that's what we have on our calculators. So 1 over, and then we're going to do one of our options. So for example, 1/2. We do 1 over 1/2 to the x. If we put that in the calculator like that, wouldn't you know it, it's 60. If it matches, then oh my goodness, we have 60, and that's our correct answer. So that's all you had to do into your calculator, is just plug in those options. So let this be a lesson to you, to know that you don't always have to do all the complicated algebra. You can instead just look at the options and try and figure out, okay, what's the variable going to be if we plugged into it. Okay, next up, we got a bit of an easier one here. This is, notice, multiplying by 3/4 every time. Okay, so multiply by 3/4, which means it's a geometric. And this means we can use our program. So if we go to Academic 22, and then we do a geometric sequence series, we know we're trying to find the sum of a series. So it's a series, a finite series, an infinite series, because notice that ... just means it keeps going onward and onward. Oh, oops, I accidentally clicked the wrong thing. So we're going to do an infinite series. We know we're trying to find the series sum, and the first item is going to be 1. And then the common ratio is going to be 3/4 because we're multiplying by 3/4 every time. And so we get 4. And so the answer is 4. Then we have find the sum of the series that. Now this looks complicated, but guess what? We can do it with our calculators again. So if we go ahead and go down from the math button to 10 summation, we can just click x instead of n equals 1. And then above 1, it says 5. So we type in 5, and then in the brackets, we put all of that. So just make sure you're typing it into your calculator correctly. But if we do 2 to the power of negative, and it's going to be x, remember, because we're using x because that's the only number we can use here. 6 to the power of x plus 2. And if we go ahead and do that, we get 1368, which is quite confusing actually. Because, let me actually check that real quick. Yeah, so our options are incorrect. It seems as though the demi-deck has decided to be wrong again. So it's going to be 1376. This is 176, which is going to be a good example of like when you just kind of need to go with your closest option that you get. But don't always do that. Don't think that way on the test because you need to get the exact answer in order to know if it's for sure correct. So let's just say this option is changed to 1368. So that's our option, and that is all for this video. Thank you for watching.